Okay, good morning, everyone. Just wait a second for my slides. So, as David said, my name is Markus, and I'm working on semantic web linked data, and I called my talk 1 billion, as you see now. And the reason why I called it 1 billion is because I think it illustrates the problems we currently face with web APIs quite well. 1 billion euros is the sum that the European Union spends every single year to translate their documents into the various member languages, and there are just 24 of them. And if you think about it, we are doing exactly the same all the time if we are building APIs, if we're building applications. So if you build an application, and the chance is quite high these days that you have to integrate with a couple of web APIs, then you're really translating back and forth between different languages all the time. And that's, of course, a tedious process, it's a costly process, and it's actually unnecessary if you would speak the same language. So just as here we all talk English, even if it's not the native language for a lot of us, it still, it helps to understand each other. So what we do currently is, if we integrate with web APIs, is we either go and read the documentation and figure out how it works, or we download an SDK for that. So we introduce dependencies, code dependencies, we increase the complexity of our application. And the more web APIs we integrate, the more complex our systems become. And if we look at it from a different point of view, if we look at it from a systems perspective point of view, then we see that the complexity quickly gets out of control. So if those APIs also need to talk directly to each other, and that's not such far-fetched, I think. I mean, if you think about Internet of Things or those kind of applications, then those things really have to talk to each other as well, not just to one application. And if we look at it from this perspective, you'll see that the number of potential integrations, of the potential translations really explodes quite quickly. So just to give you an idea of the numbers, so if we just have 10 APIs, we're already talking about 50 integrations. 100, we're already at 5,000. If we just have 1,000 web APIs, and that's a tiny number if you compare that to the size of the web, then we are already at 500 million of those integrations. And that's certainly not manageable anymore. So I think we need to, in a sense, rethink about how we build and how we integrate with web APIs. And the solution is actually quite simple. I mean, it's exactly the same problem that the web solved like 30 years ago. So it was exactly the same situation back then. You had documents in various formats, different network protocols, etc. And what Tim Berners-Lee did back then is he introduced a small set of standards that really ensured that everyone is talking the same language. And if you have that, you can get rid of all those SDKs. You don't have those n-square integrations anymore. Instead, you end up with a much simpler system. So if there is just one standard or a small set of standards, you really just need one tool to talk to everyone, basically. And that's the idea that we had a couple of years ago, and that's also what kind of the vision of the semantic web is. But as David said, it didn't get any traction because it was way too complex still very recently. And so we tried to change that. And JSONLD is the thing we came up with. So it's a very simple specification. It's a small set of conventions that you can use in your JSON-based web APIs to make them also understandable to machines, so that machines can figure out how things work, what the data means, etc. So just to illustrate that, what we do, or what the idea is, you have your data and you just add a little bit of extra information for the machine so that the machine can make sense of that data. And that way, you can really build much smarter applications, much more generic applications that you can reuse code across different applications. And if you do that, you need kind of a way to represent the concepts that you use. So for example, you need to have a way to represent, well, this is a person, for example, or this is a product. And similarly, you need a language to describe to a machine how it can interact with a web API. So in a sense, you need a vocabulary, a shared vocabulary, a shared understanding. And one of those vocabularies is Hydra. So it's a very small, lightweight vocabulary. It just defines a handful of concepts And those are very important concepts for web APIs. They allow you to express how you can interact with our API, what you can do, how you can manipulate the data, how you can get access to the data, etc. And just to give you a very quick idea of how it looks like in practice, so if you have a JSON-based web API, let's say an events management web API, and you go and retrieve a list of events, you do an HTTP GET, you would get back a JSONLD document. It would link to that context I talked about before. It would also tell you that this entity is a collection, so we type it. Collection obviously has a couple of members, perhaps a couple of other properties. And now Hydra is able to answer the question of how you can add an event to that collection. And it's actually quite straightforward. So you just extend the description of that entity, of that resource a bit. You say, it also happens to support an operation. The type of that operation is add action, so that tells the machine what happens if you invoke that operation. It tells the machine how to do that. It's an HTTP post, and what data the server expects. And that way, you can really generalize solutions. As long as they understand Hydra, they will know how to interact with your web API. So things that you can do with this, for instance, is you can create completely generic API consoles, API browsers. So you don't have to build a different tool for every single web API. And one of those generic API consoles is what we call the Hydra console. So it's very simple. It's a bit similar to a web browser. So you just paste in a URL of your web API. Then it goes, retrieves that response. At the same time, it goes and downloads all the documentation for the elements it encounters in there so that a human user sees the documentation alongside it. It recognizes hyperlinks in there, so you can navigate the API just as you navigate normal websites. If you click on a hyperlink, it will show you the operations that are available. So you can really start to interact with the API. For example, we can create a new event in this case here. If you do that, the console will render a form for you, so you don't have to be a technical expert or anything. It's really just like interacting with a website. But on the back end, it's really an API, and you don't have to, adapt or implement such clients yourself anymore. You can really just use that, and you get it for free, basically. And of course, if you then fill out that form, the Hydra console will create a request for you, send it to the server. Server again replies with a response, and the whole cycle starts over again. So those are kind of tools for developers. They help you to ensure that you build the right thing so your customers can start to play with the API, etc. But you can, of course, also create things which are a bit more for the end consumer. So Google, for example, did that already in Gmail. And the thing they did is, if you book a flight, then the airline can embed a little bit of JSONLD into their confirmation email. And then Google is able to understand that you just booked a flight. So they can extract that information. They know, you booked a flight, which flight it was, and then they can show you a nice little summary on top of your email. And that way, they can really give you up-to-date information. They can index that data, so you can, Google for my flights. They push that information to your mobile phone. They even go as far as fetching the boarding pass for you. Okay. That's all. I'm already running out of time, I was just saying. Okay. So thank you very much.